In this video, I'm going to explain how you can create a graph of a cardioid. I probably should make a separate video about how to spell cardioid because it is a very strange word with that IOI combination. The example I'll use is the equation r equals 5 minus 5 cosine of theta. And anytime you have both the coefficient and the midline the same in magnitude, the coefficient, the midline, and the amplitude the same in magnitude, you'll graph a cardioid. The strategy that I'll use is considering the sinusoid. Y equals 5 minus 5 cosine of x. So the idea is if I can think about what the sinusoid looks like, I can consider some very, very important points on that sinusoid and use them to quickly graph the cardioid. So I'll draw my midline here at 5. Now, since my amplitude is also 5, I know that my curve will bounce between 0 and 10, 5 above and 5 below the midline. Since it's a negative cosine curve, it starts at its minimum, works its way up to its maximum, and then works its way back down. As I connect the dots, the sinusoid would look something like this. And those 5 points that I've marked right there are the exact points that I want to plot in my polar curve. The first one I'll label A. The second one I'll label B, and C, D, and E. Generally speaking, maxes, mins, midlines, and zeros are the points you want to graph. Since A has coordinates 0, 0 in rectangular and also 0, 0 in polar, it'll be right at the pole. B, meanwhile, will be at 5, 90 degrees, so right up there. C is at 10, 180 degrees, so way off to the left. D is at 270 degrees and a radius of 5, so you'll find D right down there. And E will be right back where we started with A. So now all I have to do is play a little game of connect the dots. I have to connect A, then B, then C, then D, and I should always do it in this counterclockwise motion, making a little spiral. And when you do that, you got your graph of the cardioid. It really couldn't be any harder than that. One question you might have is, did you draw it accurately? Did you make it wide enough? So you could always add a few more points. For example, I can see at 60 degrees, I should have a radius of 2.5. So that matches up nicely. At 120 degrees, I'll have a radius of 7.5. So that looks pretty accurate. You can obviously add some more points that are easy to read off your sinusoid, but you don't want it to be an exercise in plotting points. So the key idea is identify some quick and important points on the sinusoid, namely the mins, the maxes, the midlines, and any zeros, and then just play a quick game of connect the dots.